Hey everyone, welcome back. I hope I'm audible. Let's get a quick mic and camera check. I hope I'm audible. Let's see. Let's wait a couple of minutes for people to join. I will just push in. Sure, maybe in meanwhile, if you want any specific resources which you want to highlight during your session and talk,
Yeah,
so you can just share that with me in private chat. So when the time comes, I will be ready to share them.
yeah, definitely.
Hello, hello. Yep, I see people are joining.
I just shared the list of things that you can share. So yeah,
Perfect, perfect. So I guess we can start. Yes, Wasm for the win, and we will be seeing today what is Wasm and maybe build a hands-on demo along with the session. So hey everyone, welcome back to another session of CNCF Nashik. In today's session, we will be seeing introduction to WebAssembly, also known as Wasm, and it was one of the topics of center of talk in at KubeCon, and why everyone is trying to know wasn't better, and why is it a field which people are keeping their eyes on in mostly CNCF and DevOps world. So we will be seeing that. So for that we have Shivay here. Most of you might know him from Twitter and all those amazing talks across conferences and events. So hey Shivay, would you like to give yourself a quick introduction?
yeah. Thank you so much, Kaiwalya. And actually, I was having a conversation just the other day with Kaiwalya that the kind of activities that he's conducting for CNCF Nashik, and especially on this channel, it's really tremendous, really nice. So kudos to you, and I hope that the channel and the the entire this entire society for the CNCF Nashik grows really well. A very quick introduction about myself. So I'm Shivay. I'm currently a developer relations engineer at Millisearch, which is a Rust-based search engine, and I it's an open source project. And my journey with WebAssembly started in 2020. I would say late 2020 when I started to contribute to the project of TensorFlow.js, which is an open source machine learning library for JavaScript that's maintained by Google. Now, since machine learning does require a lot of high compute, and especially if you were to run it on JavaScript, which is not the most compute intensive application language, you needed to use some other toolkits that can actually help you run those more compute intensive tasks. And that's where WebAssembly basically comes into picture. And of course, we'll go much more deeper into what exactly is WebAssembly. But I started by contributing to the TensorFlow WebAssembly backend for the TensorFlow.js project, and then I got introduced to the WasmX project, which is a WebAssembly runtime, and it's part of the CNCF. And since then, I have been WebAssembly WebAssembly WasmX ambassador, and that's mainly I've been advocating about the WasmX project, and I've also been helping a lot of students who are part of the LFX for the LFX mentorship. within the WASM Edge project. So that's my relation with WASM, and yeah, I'm super excited to be sharing with everyone on what exactly is WASM and how to basically get started with WASM.
Yeah, that's like pretty much just we can say a trailer about Wasm, and obviously we will be seeing much detail. And this is like if you are just getting started, like one myself, I have a basic overview of what Warzone is and etc. So it is going to be a learning experience for me as well. So if you have any questions, make sure you ask them into the chats. If you are learning alongside, make sure you document it so that uh, you don't try to just not listen to it, but try to document it somewhere, maybe write Twitter thread, tag us, tag CNCF Nasik, and we would be happy enough to retweet it and appreciate it everywhere. So please make sure whatever you are learning to share across all your socials and stuff. So
Yeah.
Shivay, would you like to share your presentation screen, anything like that, if you have prepared and get started with this session?
Yeah, let me go ahead and share my screen. 1 second. So I'll just actually share my entire screen. Let me do that. 1 second. Just give me 1 second. Yeah, please do let me know if my screen is visible. Perfect. All right. Yeah. By the way, I'll just take 1 second, Kaiwalya. I'll
Yeah,
start
yeah,
and
sure.
I'll set it up. So just give me 1 second.
Yeah, sure. Take your time. Thank you, Shivam. Great, great, great. By the way, how
All right.
many
Am I
people
audible now?
here?
Yeah.
Yeah, yeah, you are
Okay.
audible.
I'm sorry.
I was just
All right.
seeing how many people here already know what is WASM from the comments. If you didn't know in what about WASM, or if you have heard about it, let us know in
Yeah.
the comments, and I will be highlighting them side by side. Shiva, stage is all yours.
And yeah, and I wanted to kind of keep this in the theme of especially introducing like cloud native WebAssembly, because the theme for CNCF Nasik is all about Kubernetes.
Yeah,
So one of the
yeah,
common common discussion points is also some of the limitations that comes with containers, right? And there
correct.
are always these voices that come up that should containers be deprecated. And I think one of the most as you mentioned very rightly, that especially in the lead up of 2022 and going into 2023, one of the most common questions that people ask is that can we replace containers with WebAssembly? So we'll also be actually tackling that question in today's session. So yeah, please stay tuned to cover that. But for that section of the audience that is not aware of what WebAssembly is all about, so
Mhm.
WebAssembly, as it has two words, so there's web and assembly. But in a nutshell, it is neither web or assembly, because given the fact that it's called WebAssembly, a lot of people attribute WebAssembly to be a browser or a web technology, right? Whereas that it is not really a web technology per se. It's used both on the web and also extensively on the server side. And a lot of times people also compare it with assembly language. But again, you will find that there are a lot of different, distinct features within WebAssembly that is that makes it a lot more different than your assembly language. So, in a nutshell, if I were to describe it in one line, it is essentially this compilation target where you take your functions or modules written in various programming languages, and it is a polyglot environment. That means that you can use things like scripting languages like Python, or you could use your functional programming languages like C#, right? You could use your object oriented programming languages like Java, C++, and then use the WebAssembly as a compilation target, right? And it is essentially this low level bytecode that works at, or you could say, very near to how your native applications work. Of course, it's not like directly native, but it works at a very low level such that it's very similar to your native applications. It works very similar to that native applications. And what that enables you to do is that since it is such a low level bytecode, right? It is very efficient in nature, and it's very quick to be able to do any kind of processing, because it works at that near native speeds, right? That you work if you were building any native application, or if you had some kind of a bytecode that worked directly or interacted directly with your CPU. So the idea is that with the help of WebAssembly, we are able to take high computational functions that are written in these all these different languages, and then we are able to compile them down to this bytecode. And one of the biggest benefits is that it is highly portable. That means that once you have generated this WebAssembly bytecode, it can be used across multiple platforms. So it's not just limited to, let's say, being able to run on a Windows machine, or let's say on one type of architecture, like let's say an x64 architecture, or just on ARM based devices. You just compile your functions into the bytecode, and it can be used on any platform or on any architecture, system architecture of your choice, right? And so that makes it really efficient. And the added benefit that you also get with the help of WebAssembly is the security. So WebAssembly itself, right, the bytecode itself cannot really do anything. So whether it's being able to interact with your file resources or network resources, you have to basically set up the rules for it to be able to interact with the outside environment. So the way WebAssembly bytecode works is that there is a sandbox, right? The sandbox layer in which your WebAssembly bytecode resides, and whatever interaction needs to take place with the help of this sandbox. So it provides a very secure environment to run your code, right? And it is very hard to be able to break into the WebAssembly security model. And that is why if you want to run your applications in a very secure manner, that's also where WebAssembly really shines, right? And of course, in case you were wondering that is it possible to write code directly in WebAssembly? So this is just an example of a hello world program in WebAssembly. Now do keep in mind that we are not like talking about hello world as a string, because WebAssembly does not support a string as a data type. So this is an example for a integer, and you can just think like, if you were printing something like 10 or 11, which is an integer data type, we are printing that, and this is how it's written. So of course, you are not supposed to write any program in WebAssembly, although you could write if you want to. But in most cases, it is a compilation target. So you will write a function in your popular programming language, and then you will compile it into this WebAssembly bytecode that you can use later on. And of course, as mentioned, that the first thing that it's not just for the web, and it goes far and beyond today with a lot of server and of course a lot of cloud native applications that we'll cover in today's session. And this is like kind of the broad spectrum of how WebAssembly is used. So you do see it being used in a lot of different browser applications. And again, the main purpose of how the beginnings of WebAssembly started was through the assembly language, ASM.js, and that gave rise to the WebAssembly. And again, the main point was that JavaScript as a language, even though it might be great for like building applications, websites, there is a certain trade-off when it comes to the performance of JavaScript, and that's where you could basically use more highly performant programming languages like Rust or C++. Now, one of the downsides was that you could not directly use these languages or the functions that you wrote directly on the browser, because your web browser only supports JavaScript out of the box. So the way that we were able to overcome this limitation was to basically go ahead and compile your functions written in these languages into the WebAssembly bytecode, and then JavaScript could then stream the WebAssembly bytecode, and that would take care of any of the high computational tasks. So that is how very popular tools such as your Adobe Lightroom or Figma or Microsoft Flight Simulator, they work very similarly on this notion, where most of the high computational tasks are carried out by your functions written in Rust, and which are like compiled into the WebAssembly bytecode and then streamed with the help of the JavaScript. But of course, today the entire ecosystem is for WebAssembly is changing dramatically. So according to the state of WebAssembly 2022, which is a yearly report, and in fact the CNCF itself also ran a poll on the use of WebAssembly outside of the browser, and you can see very clearly that the usage of the WebAssembly for serverless applications, containerization, is growing at a lot more larger pace as compared to just your browser applications. And that also can be seen over here in terms of how the usage for WebAssembly has increased, whereas the usage for WebAssembly for the browser side has actually decreased considerably over the past few years. And that is why we'll come into the CNCF landscape and how WebAssembly is being used today in the cloud native ecosystem. Now, of course, Cavalier has covered a bit of Kubernetes and Docker, but this is like the entire CNCF landscape. This essentially consists of all the different set of incubating graduated projects that are currently inside of the CNCF. And there is a dedicated section that today exists within the entire landscape just for WebAssembly. So that basically includes the things such as the WebAssembly specifications that is run by the WebAssembly Bytecode Alliance that comes up with the new set of specifications for the entire WebAssembly. And then you have the WebAssembly runtimes, certain tool chains, and of course, a lot of the different open source projects that are built on top of WebAssembly that again we'll discuss in some time. And this is a really nice application to showcase how today WebAssembly is being used for cloud native applications. So it can be used for AIML, that's basically for machine learning. And there's really a good use for being able to use machine learning inference with the help of WebAssembly. As I mentioned, that WebAssembly is really small and it's very highly compute intensive, right? So it can work very quickly as compared to your standard containers. And that is why if you were to, let's say, run your machine learning inference on edge devices, where typically the biggest constraint that you have is in terms of the size of your containers, right? And the compute power itself, right? Because on edge devices or even on things like Arduino devices, you don't get a lot of compute. So you could run your inference for machine learning with the help of WebAssembly. But you have projects like Single Store that allow you to basically run your user-defined functions, or we also call as like user-defined protocols within databases. You see it being used in projects like Envoy for service meshes, right? And then in Open Policy Agent, you can run WebAssembly instead of Kubernetes. So we'll take a look at some of these examples. But in terms of just the cloud native ecosystem, the growth for WebAssembly and adoption for Rust programming language and WebAssembly are very huge, right? It's definitely on the rise. And again, this is a really a great example by Cosmonic, who showcased how the entire ecosystem for cloud itself, right, has evolved. So of course, we started in the 1980s with all the servers running on the bare bones computers themselves, and then we went to the VMs, which are the virtual machines. Then from virtual machines, we went to the concept of containers, which basically overcame the issue of the virtual machines, where the virtual machines were really dependent on the functions and all the dependencies that came with the applications. And if you were to, let's say, run it on some other host environment, then of course there would be some issues with the matching the dependencies, right? So we went to containers, and now we are basically gradually moving towards WebAssembly as the default runtime because of the capabilities that are offered with the help of WebAssembly. And of course, there are a lot of different types of WebAssembly runtimes. So again, these are specifically projects that allow you to execute your WebAssembly bytecode. And again, each one of them have their own benefits. We'll not go too deep today into comparing each one of these runtimes per se, but each one of them have their own benefits. Again, having different layer of supports for things like networking and then HTTP protocols. So they come up with varying levels of such those support. And of course, I mean, when you actually go ahead and execute your machine learning models, or for that matter any application with WebAssembly, then of course each one of them will have a certain set of execution time that it actually takes. Then, of course, there are a lot of different platforms today that have also been built on top of WebAssembly. And some of these are very well known startups like Fermion, which has the Spin project that is used to create serverless microservices with the help of WebAssembly. Then we have Suborbital that again acts as a layer of infrastructure as a layer on top of WebAssembly. Then we have Wasm Cloud, and of course a number of different other platforms today that are actively using WebAssembly as their core technology, right? So that this goes on to showcase that how much evolved the ecosystem is, and of course it's still at a very nascent stage, especially when we come at the cloud native ecosystem. And of course, the biggest question is that how shall we use the WebAssembly beyond the browser, right? So of course, the biggest factor, as I mentioned, is that because of the fact that the WebAssembly bytecode is polyglot. It basically can be used with multiple languages being compiled into the WASM bytecode, and also it works across multiple platforms. So the main way in which you would interact, let's say, with the file system, or for that matter, any system resources with your WASM module, is with the help of the WebAssembly system interface. Now, typically, if we talk about system interfaces or any application in general, right, the way that they interact with your kernel is with the help of these system interfaces that basically allow for the communication between any software application and the kernel, that allows you to run any specific tasks. And that is very similar on how the WebAssembly system interface, or WASI in short, also works, right? That allows you to access your system and networking resources and be able to manage interactions with those, right? In order to, in case you're doing such kind of interaction. So you do that with the help of the WASI. So you basically use a combination of your WebAssembly bytecode and the WASI in order to be able to run any run any applications, or like, let's say, go ahead and be able to use any system resources that you might need for your entire application. And one of the biggest source of contentions that people have is trying to make the comparison between Linux containers and your WebAssembly containers. Now, your standard Linux containers are generally like Ubuntu containers, and according to, various studies, and like this is a fair comparison by Lynn Clark, who basically ran an implementation for a machine learning model inference, and they compared between the Docker implementation and WebAssembly implementation. And it's definitely, very clear that if you take a look at the size of the containers, right? So the size of the container of Docker was 39 MB, and for WebAssembly it was 3 MB. And the runtime, right, the evaluation time that you can see is also very drastically different, right? It took a lot more time for the Docker implementation for the evaluation to complete. And that is why when it comes and if you compare between the size of the actual container, WebAssembly can be anywhere from 1 to 100 times smaller as compared to the size of a standard Linux container. And also the startup time for your WebAssembly containers is a lot less as compared to your Linux containers. Generally we have this problem of the cold starts, right, where if you're starting up a container for the first time, it will take a lot of time. So the startup time for a WASM container is a lot more smaller as compared to your standard Linux containers. And of course, you also get the benefit of the security isolation for WebAssembly itself, right? So given the fact that there are so many benefits when it comes to your standard WebAssembly containers, right? Then of course, the biggest question is that why not just replace your Linux containers with the help of your WASM containers? And that is because there are certain I would say not disadvantages but limitations because of the fact that the ecosystem in itself is still pretty new, right? So the biggest point where why we're not really replacing our currently our containerized applications with WASM is because of the tool chain and the existing support for libraries that comes for WASM, right? For WASM, the toolchain, the supported toolchain and the libraries is very limited in nature. And of course, when it comes to your standard Linux containers, the Linux containers toolchains, and of course, all the set of different libraries and functions that can be used alongside your Linux containers is a lot more mature. And that is in itself like one of the biggest reasons that we cannot just replace the Linux containers with the help of the WASM containers. And of course, a lot of the very important things such as networking is something that is still not very widely supported. So things like support for gRPC, or let's say socket, is something that's still being developed. There are working groups that are currently working on implementations, and it's not very widespread at this very moment. And since the ecosystem for WASM in itself is still evolving, that's why it's not meant to replace. But in fact, what the proposal is that you should be able to run them side by side, right? So the thing is that here is an example for a container ecosystem. So at the top you see your Kubernetes based applications, so whether it's your Kubernetes distributions, or let's say some of the projects that are running on top of Kubernetes. And then you have your two different types of container runtimes. So you have your high level container runtime and your lower level container runtime, and at the end you have your actual container images. So idea is that you basically run your Linux containers and your WebAssembly containers side by side. So Wasm containers are not a replacement for your Linux containers. In fact, they work very well and they complement each other side by side. So one of the use cases that you could have is that all the high compute that you want to run, and of course any application or processing that you require to be done very quickly, could be targeted by your WebAssembly containers or by the image, and rest of all of the standard operations can be conducted inside of your Linux containers, right? So an example of this could be that you have, let's say, a three pod Kubernetes deployment that you have created. So you have, one is the master node, one node could house your Linux container, and the third node could be a WASI node pool, and that node pool can actually run your WebAssembly application. So that's the entire idea. Now, before we jump into the Docker plus Wasm technical preview, and we have a demo also showcasing this integration, we like to take up some questions at this point of time. So, Kaiwalya, I think we can probably take up like a couple of questions, and then we'll move to the next part of the presentation.
Yeah, absolutely. So let's see if we have any questions here. So, uh, mm, just a second.
I
I
don't
don't
think
see
so.
any
There,
questions right
yeah.
now. Yeah.
Okay.
Do you see any questions?
No, I don't think so. There is any specific questions
Yeah.
at this moment. All right.
Yeah.
If
So
that's fine, we can.
the first question, yeah, the only question I had, like I saw a couple of days ago, there was a blog saying there is title blog title if if Wasm was going to replace Docker containers, and you pretty much solved it that high
Yeah.
compute resources can be deployed on Wasm containers, and uh, maybe the containers or sidecars, something like that, can be deployed using Linux containers, which we always do on
Yeah.
while we are getting started and something like that.
Hmm.
Yeah, so I don't think there are like many questions right now, but I pretty much think that in future when we try hands-on side by side, we will be facing lot many questions and
Yeah.
queries. So yeah, I myself had just one question that while we are trying to run Wasm containers alongside Linux containers, there might be some downfall to that as well, right? Maybe resources on the cluster or anything like that. So if Wasm is trying to reduce the computational resources taken, or if it's reducing time, then inversely it might be taking other physical resources like maybe memory, extra memory, something like that. So what are the downfalls of Wasm becoming like you being able to run the application faster than containers?
Yeah, so that's a really good question. So I would say that according to the current implementations and how, because, and I'll be covering that in a bit, is how you can basically run your Wasm workloads on top of your Kubernetes nodes, right? So you might have a node. So the simple answer is that at this moment, the support is not that very, I mean, that great. Of course, there are specific runtimes that do work pretty well. So crun is a container OCI, like a lower level OCI that works pretty well. But if you were to use like your different Wasm runtimes, they do not really have a very good support outside of, let's say, Azure Kubernetes Service and a couple of other
Mhm.
distros, right? So that support is not widespread at this very moment. But I would say that in terms of the memory, it will actually take up less memory because the overall the size of the container itself, right, the workload itself will be smaller. So I don't see any potential downsides in terms of that. But of course, one of the downside is pretty much prevalent today is the limited support for the developer toolings that is supported for Wasm. So things such as, like, when usually whenever you are dealing with your Kubernetes clusters, you want to monitor the health status, health checks, right, using Prometheus or Grafana to kind of monitor the logs. Potential issues with support of just monitoring, like, those specific logs for the WASI node pool might be a potential issue that might come up. But again, like, the amount of work that has been done in this space is still new. And of course we'll see as it becomes more mature how, like, those issues can be resolved.
Yeah. Again, before like we move on to like a demo, I had just a quick again question. So,
Yeah.
these two container and runtimes being totally different than each other on all the like architectural level or maybe conceptual level. So when we are working with containers and maybe services, we network around across them, right? So uh,
Yeah.
do WASM containers or runtime are able to like communicate with Linux containers and runtime, like or they have their own pools and service like a group going on like separately. So we have to segregate the high computational resources or services differently for WASM containers, or is there a way it communicates? Uh,
Yeah, I
yeah.
mean, as you would communicate between any two different services that might be running in separate containers, that is definitely possible to do so with your WASM containers as well. So that's not going to be an issue. And that's also, like, one of the reasons why you can basically go ahead and deploy your WASM containers with the help of Docker as well. Because normally the images that you deploy are, like, your standard Linux images. And you can also deploy your WASM images as well with the help of Docker, right, on Docker Hub or any other container registry. So when you're interacting between the services, like let's say from a WASI node pool and a Linux node pool, the interaction between them or the communication between them is not an issue. Like the way that you operate your standard communication between any other two different containers, you can do that again with the help of the WASI as well.
Oh, perfect,
Yeah.
perfect. And like the like how are the tools adapting to this WASM containers? Say suppose now we have like for monitoring we have Prometheus and such tool like focused on like maybe container monitoring or security, etc. So are
Yeah.
these tool adaptable enough to like monitor and provide security for WASM containers as well, or there are different set of tools altogether to support the WASM containers? Because the like the differences, seeing the differences, how is the take right now?
So I'm not entirely sure when it comes specifically with, like, tools such as Prometheus, because of course, I mean, those tools are more towards the monitoring. So if you are kind of looking more in terms of like security scanning tools, which kind of regularly monitor the health of your cluster, I'm not entirely sure if they have a dedicated implementation for WASM containers, because ultimately they are like your standard image, right? There's no difference as such per se between an image when it comes like a Docker image or a WASM image. Of course, like the WASM image will be a lot more smaller in size, and it will have the WASM bytecode that is running, right? So in terms of like architecturally, it's not as different. So, such that you might require a completely separate tool chain to be able to support being able to, like, let's say scan or conduct any such kind of an activity with your WASM container. I hope that makes sense.
Yeah, yeah, perfectly. And yeah, meanwhile, we have a question like WASM images versus Docker images. Is there a difference only in their sizes?
No. So the of course there is one difference that's definitely there in the size and the startup time, right? For the WASM containers. But again, one of the biggest ones is the security, right? Because the underlying technology of how a WebAssembly bytecode works is that it's wrapped under the sandbox layer, and you need like things like WASI to be able to interact with your file system resources. So the way in which basically it interacts is completely different, and that is why the tool chains that are typically used with WASM, right, with Docker, sorry, not with Docker, but with Linux containers, they cannot directly be used with your WASM, right? So that's the biggest difference, Shivam.
Yeah, thank you so much. And I guess now we can head towards the demo of the actual WASM.
Yeah.
Yep.
All right. So you can share my screen.
Yeah.
Okay, perfect. So far, like what we discussed was the difference, and again the point being that you can essentially run your Linux and WASM containers side by side, and of course it's not meant to replace. And owing to that growing idea of how WASM was becoming so popular, Docker itself announced the stable release for, or kind of the technical preview for Docker plus WASM, in which basically you can execute WASM. applications within Docker. And in fact, you can you things like, by using like Docker build, you can go ahead and publish your wasm applications as container images within the Docker hub as well. And based on this, I'll be quickly showing you an example for how Docker works with the help of wasm apps. So for this, I will open up my VS Code, and to give a bit more context as well, I'll also open up my code space. So I'll just wait for the code space to start. Till then, I'll just give a very quick overview of the code itself, right? So here I have my it's going to be a web application where I have a CRUD operation where you can very simply create like an order based on all of these different parameters, and you can
Shivay,
either update.
sorry to interrupt. I was just want to ask if this code is hosted on GitHub so we can share with people who want to
Yeah,
try
yeah,
it on website and so on.
yeah. I'll be sharing this after after this demo. So I'll
Yeah,
share this
perfect, perfect,
afterwards. Yeah.
perfect.
Yeah. So coming back over here, right? So this is basically the CRUD operation. Of course, as we'll demonstrate the code, this is just the index.html file, and the main source code that we have written is under this main.irs file. So this is a Rust module in which we have defined four different types of functions, and those are primarily to create, delete, update, and view all the list of orders that we generate, right? So here you can see that we have generated basically a structure where we have defined what will be inside of the order itself, right? So we have implemented an order object. So the order object will consist of all of these different attributes. And then we have defined all the list of different methods that we will use. So the init method, create order method, update order method, delete orders, and to fetch the list of all the different orders. And then of course we have just defined each one of these methods, and whether it's a get request or a post request. So you'll find all of these different methods. So the idea is that based on this main.irs file, we'll generate the WebAssembly bytecode, and that will be used to run our application. Now, in order to be able to do so, right, especially as I mentioned, right, that each and every language can be compiled into the WebAssembly bytecode, and of course it has they have their own set of tool chain that allows them to do so, right? When it comes specifically to Rust, we can use the cargo build, and by specifying the target as wasm32 wasy, that allows you to go ahead and generate the WebAssembly bytecode from your main function, from your Rust function. If I just run this, right, it will basically go ahead and generate this target folder, right? So in my case, since I had already generated the target, it was able to complete this task in 3 seconds. Usually, depending on the size of your module, it might take a few seconds, up to let's say a minute. But if I go into this target folder and inside the release, right, and over here inside of the WASI32 and inside of the release, you'll see that it basically generates this order demo underscore service dot wasm file, right? And this is the wasm file that has been generated. This bytecode has been generated from our Rust function that is over here, that the main.irs function, right? We use this to build it and generate the WebAssembly bytecode. Now, what you can do is that you can basically go ahead and run this WebAssembly bytecode, and if you actually want to test it out, you can test it out. So here is a sample command, and what we are using over here is the wasm-edge runtime. So wasm-edge is also one of the popular WebAssembly runtimes. So of course, if you want to execute any WebAssembly bytecode, you have to use a accompanying WebAssembly runtime. So you can choose any runtime of its choice. I'm using wasm-edge as an example, but if you have like wasm time, Wasmer, there are like number of different WebAssembly runtimes. So you could run this, and of course this one is just connecting with the database. So we're determining the database, and it will execute and run with the database. So if we execute this over here, you can see that it will run on port 8080. So I can go ahead and open this on port 8080, and you can see that this is basically the init order, where you can see that these are the list of all the different endpoints that are supported. But coming back, so after having given you an overview of what exactly is there in our application. Coming back to our main idea of how, Docker is actually interacting with our WebAssembly bytecode. So here I have defined my Docker file, right? And this basically does a few things. So the first one is that, as I showcased, right, where we ran the cargo build, and in order to generate the WebAssembly bytecode. So the first section of my Docker file is essentially doing that, right? Where we are first installing Wasm, then we are using our cargo build, right, in order to generate our WebAssembly binary, right? So first we'll build the binary, and then we'll generate the binary, and then we'll go ahead and run our application in order to basically we'll go ahead and run our application, right? So this is simple Docker file that's essentially doing these two steps that we just ran in this in the code space. And then the other important thing to take care of over here is the actual Docker Compose file, where you can see the three different services, right? So the first service is the client, which will basically run our front end HTML application, and for that we are using Nginx. That will help us to run our front end application on port 8090. Then we have our server, which will basically run our demo microservice that is our using our Wasm executable. And the final one that we have is our actual database, where we'll be using our MariaDB to store all of our orders that we create and to fetch the list of orders. So using this Docker Compose file, and again, I'm not sure, Kevin, did you cover Docker Compose in the Docker tutorial?
No, I haven't covered Docker Compose.
Yeah, yeah. So you
I
did
will be
cover it.
making
So
separate video.
yeah, yeah. So essentially, what Docker Compose allows you to do is that instead of, let's say, having separate Docker files for each of your service, and having to run like Docker build for each one of them, if you just use Docker Compose up and you mention all the different services, it will create the images for all of them, right? It will create the images for all of them at once. And of course, you can define, what should be the order in which it should be done. I mean, we'll not go too deep into it. But what I'll do is I'll simply go ahead and use Docker compose up, right, and actually go ahead and build our application. So as you can see that once it does that, if I go to my Docker desktop and if I go to my containers, right, you can see this microservice Rust SQL, and over here you can see that there are three different images that I have. So one is the server, which is basically running my Wasm microservice. Then I have my client that's running the front end and my database. So now if I go to the local host 8090, right, this is my actual application that is running, right? As you can see, we are using Nginx for the website, Wasm for the backend, and MariaDB for our database. So let's go ahead and create a new order. So I'll just give some values over here for the order, and I'll give the quantity, I'll give the amount, and the tax details, and let's say the shipping amount. I'll just fill out these details, and I'll give it, and then I'll go ahead and generate the order. So as you can see that it generates the order, and you can see the order come over here. And I'll just refresh my screen to showcase that it's not happening on the front end. It's basically taking it from the back end. And then of course I can create more orders if I want, or I can also go ahead and delete the order, right? So it's that simple, right? That you generate your WebAssembly microservice, and it compiles your actual Rust application to the WebAssembly bytecode, to the binary, and you run that binary with the help of your Docker image. Now, of course, the next step could be that you could, if you wanted to, if you wish to go ahead and actually deploy this application, I'll just stop this, right? And you could go ahead and actually use a Docker build and publish this application as an a container image on the Docker registry, right? So that's the main point behind the Docker support, or basically the Docker plus Wasm technical preview. Now, in case you also want to try this out, you will have to install Docker Desktop 4.15. And when you go towards the technical preview, there is a specific since it's a technical preview, it's not production ready. There is a specific feature that you have to enable, and that's basically use containerd for pulling and storing images. You have to turn this feature on, and then you'll be able to use Docker with Wasm. So that was the quick demo for the Docker plus Wasm preview. But just continuing on this, right, the next question, of course, comes is that can you basically run your WebAssembly workloads in Kubernetes. And that's completely possible. And the way that we do it is, right, so if you take a look at the standard architecture of Kubernetes, right, so whenever you want to interact with the API server and you're interacting with the help of the worker node, you will usually have your containerd and your shim APIs that basically interact with the actual container image itself, right, that allows you to interact with the worker node. Now, instead of using your standard shim, right, what we have replaced over here is we have replaced it with the containerd wasm shim. And this containerd wasm shim is responsible to interact with your WebAssembly binary or your WebAssembly workload, right? So that's the main difference between your standard implementation whenever you are working with any worker nodes, and as compared to when you were to run your WebAssembly applications or workloads. So you need to use dedicatedly the containerd wasm shim in order to be able to run your WebAssembly workloads. So the idea is that you could have, as I mentioned earlier, that you could just simply have your cluster. One node pool could be your set of Linux node pools, and then separately ones for your WASI, right? So that will only run your WASM workloads, and you could manage both of them together side by side inside of a single cluster, right? So that's the architecture that you can use. And I have a demonstration just for that over here. So this is like a demo video that I just run. Again, owing to the time. So over here, what you can see is that I'm basically applying a specific WebAssembly workload, right? Using the kubectl apply. And if you see the logs, this is a log that came from the WebAssembly workload that I ran. Now, if I take a look at all of my different pods that are running, you can see that there will be a dedicated pod that is only there for the test for the wasm test workload that I ran. And you can see that it completed. And of course, I have the rest of the services that are basically running. If I just show this over here, so you can see that the workload ran correctly. And over here, you can also see that the wasm operator, key wasm operator is also running. So this is a quick demonstration to showcase how, to run how to basically run your WebAssembly workloads inside of the Kubernetes clusters. And again, of course, these are not just the applications that are there. Single store uses it for cloud databases. Of course, Kubernetes itself, you can use a crusted project to run your WebAssembly workloads on Kubernetes pods. You can use one of the newer technologies, Run WASI, that also allows you to do the same thing. Then KubeEdge is allows you to run your WebAssembly applications on edge devices. So these are, of course, like some of the other applications that are currently running on top of WebAssembly. And these are some of the resources. So you can take a look at these resources. We have already shared the slides as well. But yeah, with that, the coming to the, of course, like the summary, right? That why does WASM need Kubernetes? Because of the fact that Kubernetes has such a huge environment, right? And of course, you need some kind of a container orchestration platform. And Kubernetes is the default container orchestration platform. And similarly, Kubernetes needs WASM because of the benefits that comes with the WASM containers, and those can be implemented and can be run alongside your standard Linux containers on top of your Kubernetes cluster. But yeah, I mean, that's pretty much it. So of course, at this very moment, like, WebAssembly inside of cloud native is still evolving, and but it's definitely a very good space to be in, because Rust, as a programming language, is being highly used inside of a lot of like cloud native applications, and Rust actually has one of the best toolings for WASM. So it becomes like an ideal language to run with WebAssembly instead of your cloud native applications, right? And of course, it's not meant to replace the Docker containers, your Linux containers, but essentially work side by side. And of course, at the same time, it also does have a lot of like really great usage for serverless applications as well. So your very popular tools like Vercel are today using WebAssembly containers to be able to run edge applications or edge functions. So you also will find a lot of usage for it on the serverless side as well. But yeah, that is pretty much it, like what I had to cover, Kaiwalya. We'll be more than happy to take up now the questions.
Yeah, perfect. Actually, that was a like great demo because like Wasm seems to be like different from Docker, because Docker is from like past it is viewed as
Yeah,
one place to run your or build your Linux containers, and now Docker is like encouraging Wasm containers as well, and like kind of spreading awareness that Wasm container is a thing and can be uh, can be a great addition, and
yeah.
like seeing its feature and evolvement into the ecosystem, it is going to be really great. So like what are maybe your thoughts? I don't see any questions, so please if you have any questions, please do ask, but I will just go ahead and ask you the questions from my end. Like what are like thoughts on your end for like if they're students and they like I like myself who like feel WASM is like great and like new area to explore into while
Yeah.
working in CNCF or DevOps ecosystem, and like what are like job perspectives for WASM, because considering it relatively new, I have seen a couple of startups actually started working with WASM. So what is like a current scenario in job perspective in WASM?
Yeah, I see. I would say that the first and foremost thing that we have to keep in mind is that WASM is not a new technology. The concept of being able to generate these platform independent bytecodes and being able to run at near native speeds, right? It's something that has always been there. And the biggest example of the JVM, right? Because your Java virtual machine essentially does that. That you take your byte. I think it's a bytecode that we generate that you are able to generate with the help of your JVM. And then of course it also has its like its entire security model on which basically your Java programs work. But so I mean the underlying technology of how WebAssembly operates is something that's not that new. It's just that recently the benefits of using WebAssembly has grown so far that it's more and more people are realizing its potential. So, of course, there are a lot of different like cloud native startups that are actively using WebAssembly in their workloads, and so there are definitely job prospects in those areas. I would say I mean, of course, like the adoption is not to such an extent where it's still like that kind of a disruptive technology that has completely overtaken. But that's what the years 2023 and 2024 are for. You'll see a lot more of cloud native projects adopting technologies like Rust, WebAssembly, ePBF, and they'll kind of become the mainstay for the cloud native ecosystem for 2023 and 2024. So there will be a lot of like potential job opportunities that will come up. And if you are like, let's say, a student right now, so WASM Edge is actually accepting or it will begin accepting proposals for the WASM Edge project for the LFX mentorship. So ensure that you do apply for it. I'm not entirely sure if there are any other WASM specific um, projects under the LFX right now, but you can definitely go ahead and apply for that. Uh, and then of course there are a lot of different other open source projects currently under WASM. So things like the WASM cloud project, and then you have spin, right? So all these different other projects are also built on top of it. And I mean, in most of the other cases, WebAssembly is basically used as a part of the tooling itself, right? So your entire project will, it's not like your the entire project highlight is WASM, right? WASM will be used in some kind of a use case. So you'll not like really find a lot of projects that are, hey, like they are completely built on top of WASM. WASM will be used as part of a tool chain, and it's meant to be in such a way, like it's meant to be used in such a way, right? WASM as a technology in itself is not something that people will just use directly. They will use it as part of some kind of other entire end-to-end workload, where they will use the capability of the the benefits that you get with WASM. So you can search for such kind of projects, and you'll find a lot of them. I think Kaiwalya, I'm not sure if is it my screen or your screen is lagging a bit. Let me just check. I'm not sure. Is it just by like perhaps could the audience comment in case is it on me, or is everyone able to hear Kevalya? Or because I think that for me his screen paused. Um,
I'm so sorry. Am I audible now, Shivay?
yeah, and I just thought that it was probably on my end that I was not able to hear you.
I'm so sorry. I think my internet just got disconnected for some reason.
Yeah, yeah, not an issue at all.
Yeah, so yep, coming back to the topic after the disturbance, but as you said, like WASM supports like multiple languages across because at the end it gets compiled to bytecodes, right? So
Yeah,
and you demonstrated the application in Rust. So when we get started with DevOps, like it's suggested that go with Go language because it's like most adapted and like most projects use it like on like entire 93% or 95% of the project is built using Go. So how Rust and Go are like going alongside wasn't so should we uh, maybe start going with Rust? Obviously, Rust is already there in many projects, but if I want to stick with a single language as getting started with DevOps, so should I just get started with Rust by from start, or should I like maybe do both or go, like start with Go?
yeah. So I'll kind of point out two things for this, and again, like this is fairly common to like get this kind of a question. So first of all, as I mentioned, that WebAssembly is like not, it's not going to decide like whether you'll take up DevOps or you'll take up WebAssembly, like web development for that matter. WebAssembly is just a tool, right? And so the point is that, and since it's a polyglot tool, that means you also have support for being able to execute your Go modules inside of WebAssembly. And there's a specific version of Go that's called Tiny Go. It's a like type of Golang. I mean, it's just, I'm not entirely sure what's the main differences, but it's like compared to your regular Golang, it's a minified version. And Tiny Go has direct support to be able to like generate the wasm executables. So you could use it with that. So you don't need to learn necessarily Rust if you want to dive into WebAssembly, right? Because ultimately, as I mentioned, that you could use any programming language. You could be a web developer and interact with wasm. You could be a DevOps engineer and interact with wasm. And it's not that you need to learn Rust. Given that fact that yes, Rust does have an extensive tool chain, but that should not be the motivation for you to just learn Rust instead of like let's say learning Go, because just because the tool chain support is better. Because ultimately wasm, as I mentioned, will be used as part of your entire end-to-end ecosystem, right? Whether it's like deploying some kind of an application or doing some kind of an inference, it will be part of your workload, your entire end-to-end like system, whatever you're building. So it should not be the deciding factor for what programming language or what tech stack you're choosing. Unless and until that, yes, like WebAssembly is not only supported, because there are still some languages that do not have a very mature tool chain supporting WebAssembly. So you just have to keep that in mind. Otherwise, like it's not really a question of WebAssembly decides whether you wish to like start Rust or Golang. I think we lost Kevilla again. I'll just try to refresh. Okay. I think Kevilla joined
Yeah, so
again.
sorry.
Oh, not a short.
It's happening again. I am not sure why what's happening with my internet connection.
Not an issue.
But yeah, no worries. But yeah, would you like to give some closing remarks? Because I think like the as law like as projects and tools are more adapting towards like wasm it's like better to get your hands dirty as soon as possible. Try to work around it, mess around with it, and if you find like time and interest, then maybe contribute to it. So
Yeah.
like what are your closing notes for a student who is watching this session for the first time and want to get started with CNCF and things like WASM is like kind of new thing they have heard today.
Yeah, I mean, I would just say that for getting like good at WASM, it's very important to. It's very like it's kind of an imperative to also learn how your system architectures work, how assembly language works, and how like So I mean, you need to have that kind of an understanding, and then you can learn about the WebAssembly essentials, how to write, let's say, WebAssembly programs. How does the memory access work in WebAssembly, right? What are the data types in WebAssembly? So all those will give you like a context of the inner workings of how WebAssembly basically works and how it interacts with data, especially like from the memory perspective, because that's one of the most important concepts to understand or keep in mind. And from there on, you can go ahead and take a look at how different tool chains allow you to build WebAssembly modules, how you can run those WebAssembly modules with the help of the different types of runtimes. Then you can study about WASI and how WASI can be used alongside WebAssembly, especially for any kind of like file system interface activities. Then you can move towards the WebAssembly WOGI, which is basically the WebAssembly gateway interface that allows you to interact with network resources, right? So that's the kind of approach that I'll recommend to everyone if you wish to go deeper into the inner workings of WebAssembly. So the two main things is understanding how the memory model works in WebAssembly, and second is the WASI, right? Because WASM plus WASI is what will allow you to be able to work with any system applications, or especially in when you're interacting with WebAssembly in cloud native applications. WASI is like the, I mean, the way to go through it.
Yep, perfect. So make sure you follow Shivay on Twitter. So I am sharing Shivay's Twitter handle. Shivay shares a lot about CNCF ecosystem and DevOps on Twitter, and he like if you have any clubs, etc. Make sure like you reach out to Shivay according to his availability. I hope you will be able to provide the same knowledge on your community and club. If you learned anything new in today's session or anything like that, if you got introduced to Wasm for the first time, make sure you yeah, today this internet is getting a lot on me. So sorry for that.
Not a sure at all.
Yeah, I think it's just time to uh, close the stream. The internet connection is totally weird. I hope the session was good and informative. Please make sure you share your learnings on socials, tag us, tag Nashik, tag Shivay, and we will be happy to like retweet it and comment on your learnings. And yes, see you soon in the next CNCF initiative event, etc. There will be videos coming out on Kaiwalya and other such great tools in the future. So stay tuned and see you in the next one. Bye.
All right. Thank you.